Hi, everyone, and welcome. We're going to give everyone a few minutes to jump on, and then we'll get started. Okay, so good morning, afternoon, or evening, depending on where you're tuning in from. Thank you for joining, and welcome to the webinar, How to Make Your SaaS Application Resilient by Going Multi-Region. My name is Kathleen Tassa. I'm a member of the pgEdge marketing team. For today's presenters, we are pleased to welcome our co-founder and CEO, Philip Merrick, and solutions consultant, MJ Josephson. We also have co-founder and CTO, Dennis Lucier, and customer success advocate, Harry Karan, who will be on hand to answer some of the questions that you will be asking during today's webinar. And speaking of questions, feel free to type in a question in the box located at the bottom of your screen. We will answer them during the presentation or live at the end if we have time. If we don't get to all of your questions, we'll be sure to get back to you personally after the webinar and answer anything that you have asked. But before we begin, and I hand it over to Philip, we would like to share a short video which may resonate with many of you.
Hey, Curtis, thanks for quickly jumping on a Zoom with me. Looks like we're down.
Hey, Philip. Yeah, it's not a good start to the day. Our cloud provider is down, and so we are too. They've been down since about 9 a.m.
The whole cloud or just one region?
Yeah, it's their main US East region where they're having problems. That's where we have our database and the entire application stack stood up. Hopefully it won't be another 4 hours again like it was with the last outage.
I hope so too. Please keep me updated. I'm already getting a lot of direct calls from customers. On days like today, I kind of regret giving them my cell phone number.
Look, Philip, you've been down for over 2 hours. What am I supposed to tell our customers? We have an SLA with you for 4 nines, so we'll definitely be claiming credit this month.
I fully understand, and frankly, I'd feel the same way if I were you. We are doing everything we can on our end, but since it's our cloud provider that's down, there's not much we can do.
Well, I saw they're only down in the main East region. Can't you just fail over to another region?
I'm sorry, but we're just not able to do that right now. I'll be talking to our engineering team about that so we don't have to all suffer through this again.
I'm not sure that's good enough. I mean, we love your app, but this just isn't acceptable.
Hey, Curtis, what's the latest? I just got off a Zoom with our biggest customer. They were polite, but they're already talking about claiming service credits, and they might go further than that if we're down much longer.
Yeah, I know. It's got to be tough talking with customers in these situations. Unfortunately, we still don't really have any updates from the cloud provider, so I'm not sure what to tell you.
The customer asked, why can't we just fail over to another region? Why can't we?
Well, remember all our product planning meetings. There's a line item in the roadmap that says multi-region support, and we keep deprioritizing it. Engineering's wanted to do this for a while, but it's a big lift, and the go-to-market folks always want more features. So here we are.
Why is multi-region so hard and so time-consuming?
Well, we really need our database to run across multiple regions so we can switch to another region quickly and safely, but we're totally single region right now. Our database is so big that restoring it into another region from backups takes hours, as long as these outages in a lot of cases.
Wait a second. One of our investors is pinging me. He wants to talk to both of us. Let me add him to this Zoom. Hang on.
Hey, team. So let me guess, we're down because US East is down again. That about right?
Yep.
This isn't good, folks. Aside from the customer impact, it just doesn't help with the fundraising discussions we've got going on the next round. What I really need to know is why are we tied to just this one region? Why can't we be running in another region right now?
Well, it's hard.
And the database piece especially is hard.
Guys, I don't think that's true. This problem's been solved. It turns out we just made an investment in a new company called pgEdge. They do distributed Postgres across multiple cloud regions and provide ultra high availability. You guys need to check them out.
Hello again. I'm Philip Merrick, CEO and co-founder of pgEdge. Thank you so much for joining us. That video may have hit home for a number of you. It certainly hits home for us. We have lived exactly that scenario in several SaaS companies that we've been involved in running. And so we're here today to talk about how we make it possible to make your SaaS application multi-region if you happen to be just tied to a single region. So this is directed primarily to SaaS companies, but it's actually applicable to all applications in the cloud that rely on databases. And to be clear, we're focused on Postgres, so this is very much Postgres-centric. But we'll talk a little bit more about the role that our distributed Postgres plays in making multi-region possible. But first, we'll take a look in a bit more detail at the need for going multi-region. That video, we think, spells out the biggest reason avoiding cloud outages. We'll dig into why multi-region is hard, at least until now, how our pgEdge distributed Postgres database product makes multi-region possible. We'll talk about different approaches to applying our distributed Postgres to multi-region database deployments. We don't want to forget about the other components of the application stack. It's not just all about the database, so we'll talk a little bit about that. And I'll be handing over to my colleague, Mike Josephson, who will be giving us a demo, and then we should have quite a bit of time at the end for your questions. So we're excited to present this to you. It's something that we've lived through, and we're just so excited that we're able to share this solution with you. Okay, so the biggest reason for wanting to go multi-region, we highlighted in the video. Region-wide cloud outages happen. Many of us have lived through this. Just back in the spring, Amazon, with their US East 1 region, had a 4 to 5 hour outage. Around the same time, Google's main Western European region was down for some customers for as much as a day or more. So we don't want to beat up on the cloud providers because they provide amazing, amazing infrastructure services globally on a 24/7 basis. But from time to time, these region-wide outages happen. And so you really have to think about how you're going to respond, how you're going to plan for that. Now, many of you will have already taken advantage of the availability zone capabilities of your cloud provider to be able to fail over to a different availability zone when one of them becomes unavailable. But that's all within one region. So that's obviously not enough for dealing with a region-wide outage. Now, in the earlier days of the cloud, when your cloud provider was down, you'd be able to say to your customers, it's like, hey, look, our cloud provider's down, there's not much we can do about it. But increasingly, customers are more sophisticated about this, and they're not as accepting of this reason, particularly when there are ways of architecting to be multi-region. Now, there are other reasons for wanting to go multi-region, and some of those include being able to achieve lower data latency for your remote or more remote users. So the idea here is if you have multiple copies of your database and application stack in different geographic regions, and you place those close to where your users are located, then everyone is going to see a much more consistent response time in the application, and as a result, have a better customer experience. So lower data latency, leading to improved response times for your more distant users. That's one great benefit beyond just being able to be resilient against cloud outages. But aligned with avoiding cloud outages is the fact that when you go multi-region, it provides a way of doing rolling upgrades. So you can literally go to a zero downtime or almost zero downtime maintenance scenario. With Postgres in particular, it's necessary to bring the whole system, the database, down absent distributed Postgres to be able to do the major upgrades. And then another benefit from going multi-region with distributed Postgres is it can also provide a clean solution to the data residency problem. And the idea being that to meet, say, European regulations, you need to be able to keep local data local while having global data replicated. So this can provide a clean solution to the data residency problem. We won't go into any more detail on that. That's a topic for a whole nother webinar. So why is multi-region so hard? Well, it's really about the database. Primarily, it's the database that makes it difficult to achieve a multi-region deployment. And that's because your database really needs to be continuously replicated to the other regions that you might want to fail over to. Unless your database is really quite small, like really small, it's just simply going to take a lot of time to restore from a backup. So in the case of an outage, switching to another region by bringing up another a database copy from a backup, that's really not practical. That restore process could take even longer than your actual outage. So that's not practical. And so we need to have a way of keeping databases in other regions, whether it's one or multiple, replicated and in sync. Now you can do this with synchronous streaming replication, which is what people typically use to maintain read replicas in availability zones. But your writes, when you're going across regions, are typically going to be pretty slow, depending on that distance. And depending on your application, the latency involved there might just be too much for your application to bear. Now, Postgres does have native logical asynchronous replication, but it's somewhat difficult to run that at scale. There's also a popular extension called pgLogical. It's been around for some time. And with these solutions, you're missing some things that you really need to do this kind of at enterprise grade. If you are looking at going multi-master and taking read-write traffic at each node, we'll talk about that in a minute, you're going to need a conflict resolution mechanism. And you'll probably need that also to help you with any managed failovers that you might do. Some of the existing Postgres asynchronous replication capabilities have some issues with running at scale. So you've got some fault tolerance issues to deal with there. You need support for being able to bring back a downed node. So the replication obviously stops when a node goes down. And so you've got to have a way of catching that back up so that it can rejoin the cluster. And then finally, you need some way, if only for giving yourself the assurance that you need, you're going to need some way of ensuring that the replicated databases are in fact in sync and that all of the data is getting fully replicated to the other region. And the things in the blue box there with the pgEdge logo, those are actual capabilities of our product. So our product is pgEdge Distributed Postgres. And here's how we make multi-region possible. So we provide an asynchronous logical replication capability. We do that through an extension we call Spock, which is derived from the original pgLogical extension. That comes with configurable conflict resolution and what we call conflict-free delta columns. So if you are using our distributed Postgres in a multi-master fashion with read-write traffic accepted at each node, this allows you to manage the conflicts, and the conflict-free delta columns are for aggregates, running sums, balances, and so forth, to ensure that when you've got changes made in multiple locations, the deltas for those changes are captured in the multiple locations, and all of those deltas are applied so that you do get to eventual consistency and get to the right answer on that. We've incorporated enhancements into pgLogical for greater fault tolerance, greater performance, and we have support for ultra-high availability. And we do that both in the traditional fashion with read-only streaming replicas in the region, but then also obviously across regions, which is what we're talking about here. And then we also have this piece of software we call the anti-chaos engine. And the job of the anti-chaos engine is to ensure that the databases do remain in sync. So, you might be replicating into the millions of rows within a number of tables, and it will run and make sure that the databases are actually staying in sync. So that's kind of your insurance policy to make sure that everything is happening as it should. So how can we architect our database deployments in a multi-region configuration and do it in a way that makes sense for our application? We've got a number of choices here. The simplest is you use your additional region or regions as fully passive standbys. So you've got the replication going out to the other databases. They're running very, very close to the state of your primary database. And they're standing ready to take over should your primary database go down. So that's fairly simple to comprehend. But those nodes are not actually taking any transactional traffic. So another scenario is you actually have the additional region or regions take read-only traffic. And that allows you to get a better level of overall global performance for your application. But the fact that you're taking just read traffic means you can avoid conflicts. And that's not going to require application changes or application schema changes. And then finally, you can take full advantage of the power of pgEdge and its ability to do multi-master asynchronous replication and have the additional nodes in the separate regions take both read and write traffic. But if you are wanting to initially just solve for the cloud outage problem, then you might want to just start with fully passive standbys or having the additional nodes take read traffic only. So we spent a bit of time there talking about the database layer, but what about the other components of the application stack? Well, of course, you're going to need to reproduce the application logic in each of your additional regions. So whatever infrastructure you're using, Kubernetes, whatever, for managing your application logic, you're going to need to reproduce that identically in those other regions. For that to be successful, automation is absolutely essential. So if you've been configuring your cloud infrastructure through the console, now is the time to eliminate that manual configuration work and move to a tool like Terraform or CloudFormation or similar for defining and automating the cloud configurations. You're going to need to have automated deployment of all of your code. And so you'll need to have a solid CI/CD toolchain in place, and you'll want to adjust that to deploy to multiple regions. And that's how you're going to keep everything identical in each region. Some good news though, for the database layer, our pgEdge cloud offering actually handles all the infrastructure and security configuration for you and make sure it's identical, make sure things are locked down identically in each region. So you'll only have to worry about handling configurations, cloud configurations for the application layer. And the presentation layer is probably pretty straightforward. You're probably using a CDN, a content delivery network like Cloudflare or similar, CloudFront, etc. And that's already global and multi-region by default. And finally, you're going to need to think about how you handle node failure. And the best approach to that is to configure DNS in such a way that when a node goes down, the traffic automatically fails over to the surviving node or nodes. You can also use database connect strings to achieve the same result. And so having covered the landscape there at each of the layers of the application stack and talked a bit about how pgEdge Distributed Postgres solves the database part of this problem, I'd like to hand things over to my colleague, Mike Josephson, to give us a demo. And I'm going to stop sharing my screen. MJ, over to you.
Awesome. Thank you, Philip. I appreciate that. Some excellent insights there. And when I was really thinking about a demo, I really wanted to look at this from multiple different perspectives that I hear commonly in the field. The perspective of setup and configuration, automation, as well as actually walking through a real world example that I've seen multiple different times. And so when it comes to that setup and automation, really what made the most sense to me was to actually do a demonstration of the pgEdge cloud. With the cloud, we're really automating and simplifying the deployment, the setup, the configuration, the security of setting up pgEdge in a manner that really aligns to what your own cloud strategy is. So whether you're leveraging AWS, Azure, GCP, we want to be cognizant and flexible to meet your specific business requirements, whether that is to leverage AWS or Azure or both. So really, what I'm going to be providing is actual sneak peek of the pgEdge platform, this cloud platform. This is still not GA yet, so I'm giving you a sneak peek. Don't tell the engineers. But I want to pull that up, actually kind of walk you through what's available there. And then I'm actually going to roll back the covers a little bit and show you effectively what that actually means. So what are we actually doing there? So with that said, I'm going to pull up the cloud. What you see here is an overview of what I've configured already. So I have a couple of clusters that I've created here. You can see where the nodes are for those particular clusters. I have the ability to create a new cluster. So I can specify some key considerations here. So I want this to be a global application. Something I hear commonly, I want this to be leveraging my AWS account so that I'm deploying easily and intuitively into the respective regions that are most applicable for me. I can both select that through some type ahead functionality here, as well as visually on the map. But we support a wide selection of different regions there. You can actually see as I'm going through and I'm setting up and configuring these different regions, some of the information on what's being set up under the covers. Things like IP ranges, VPCs, having that VPC peering. So really reducing the time and complexity that it takes to set these key considerations up. So I can specify different versions of Postgres. In this case, I want to use 15, but maybe I want to use 16. If I know what type of horsepower I need, maybe I have a heavy workload, I may need to spin up something a little bit larger. I have the flexibility of doing that. If I already have some key pair access configured for my AWS account, I can specify my key pair here, and I can easily and intuitively access my created resources. I also have the ability to specify or reduce the access to the end deployed resources so that, say, for me, since I'm doing the actual development, I only want to have access to it. I can do that. This is being designed in a manner that's flexible to your business requirements. So as the application evolves, as you move to production environment, maybe you want to just have your application servers open to the wild and your data layer in an internal network. The way in which the pgEdge platform is setting up and configuring these components makes it easy and flexible to adapt to your specific business requirements. And then from there, I can deploy that cluster. What you're going to see is a set of resources that are then being set up. What those steps are, very fast. I mean, realistically speaking, we're looking at 5-6 minutes to set it up, and what you get on the output of that is your key information on the cluster, the nodes associated to that cluster, some of the core metrics for those setup resources. So I have visualization both at the aggregate level across all of my nodes, as well as on the specific node level. So instead of me having to go to a specific external tool or to each of the servers individually, I have that kind of central location that I can work from. Now, that said, many of our customers have pre-existing visualization tools that they'd like to use. And in that case, that's fine. We can make those metrics available as well to those, no problem at all. We also have the ability to do some level of troubleshooting and review of the actual servers there. So you can see here, I've got both my server level logging as well as my Postgres logging. So I can actually dig into what's transpiring there if there is some type of maintenance or evaluation that I need to do. But if I'm actually to dig one layer deeper, so I'm setting up these clusters, what's actually happening under the covers with AWS. So what you see here is, this is my AWS instance. You can see I have deployed resources here. It's when I go through that process of hitting that deploy configuration, it's really simplifying that setup and configuration of the different compute that I need, the different security around the VPC, the IP configuration, the route table. So as another example here, let me just pull up VPC that you can see here, the one that literally I just stood up now. Another example here, you can see kind of that resource map of the different components that are being set up. Like, honestly, after I went through the process of using the pgEdge cloud, I never went back to setting up manually, because there's just so many different ways that pgEdge cloud is accelerating the deployment, the setup, the security of my infrastructure, that it just reduces my time tremendously. And it pulls out like those manual error-prone steps, because it's easy for me to screw up a subnet or a route table or something along the lines of that. By having it automated based on my configuration settings, it really reduces the chance of error. It really ensures that the deployed resources are interconnected in the manner that are needed, that I can be assured that my data layer is where it needs to be. So it's really powerful part of the platform. I can't stress enough how this has been tremendously helpful for me, because I just, honestly, I can't go back to the original way, because it's just setting up manually just takes too much time. I want it to be ready in a matter of minutes. So that said, once it's ready, like, how do you handle that resiliency, that data resiliency, that application resiliency? So back to that use case that I mentioned, you have users in the US, you have users in the European Union. It's really common, right? For that, I might have respective data nodes close to my end users. Maybe I have a tranche of users in the West or the East of the US and in the EU. And what I want is the best latency for those end users. I want low latency. I want quick access. I want that responsiveness to the user's interactions. But that said, as Philip mentioned, sometimes situations arise, regions go down, and I don't want my end users to be penalized because of these challenges that a cloud provider may have. I want the application to be resilient and still running in the case of some type of catastrophic issue, such that an actual region goes down. So what I actually want to do is I actually want to walk you through this use case and how pgEdge simplifies the configuration setup and fail tolerance that's required for a modern application. So that said, I have an application, so I built out that application tier. This is on top of the pgEdge database. So let me log in real quickly. Now, a couple things to note about this application. I'm leveraging the Northwind database. Really wanted a set of data that everybody's familiar with, right? So you're going to see within the application things like employees and products, because we're sitting on top of that database. I configured this in a 3-node cluster, like what we set up just minutes ago. We have a US West, East, and EU West multi-master configuration. And this is emblematic of that application layer. Ultimately, there's multiple ways in which you can handle the application layer. You can leverage DNS, you can leverage connection strings. This is just one example to show you the flexibility of the data layer. Now, when I load in, you're going to see a couple of key pieces of information here. One, I've got the different sections aligned to my Northwind database. I have a visibility into my current cluster. I have 3 different nodes as a part of that cluster here in my US West, US East, and EU West, and you can kind of see them visually located here on that map. I have the ability to pull up information on specific employees, right? So I can select that employee number. You can see reflected information for that particular employee. And as I'm accessing each of these specific nodes, you're going to see here which node I'm currently interacting with. I also have the ability to make changes to this information. So as an example, Nancy's number is wrong in this case. Let me update that real quickly. I can quickly update that. And what you're going to see is that that data is being replicated across all nodes within my configuration here. Now, this is multi-master, so each of these nodes are both read and right, so I can make a change to US East as well. But before I do that, what I'd actually like to do is reflect what would happen in the case of, let's say, a region goes down. So let me go back to my, let me set this up. So what I'll do is I'm going to make a quick change to some data in the US West node. I'm going to take that node down, and how I'm going to reflect that zone, that region being down, is I'm going to take down my EC2 instance, right? So that node is no longer available, representative of what that catastrophic failure for that region may effectively look like. So with that said, let me go ahead and pull up my environment here. Let me make a quick change to my employee phone number. So different. Update that. I'm going to come in here. I'm going to go ahead and stop my instance there. So now just double check. It's no longer in a running state. I'm going to come back to my application here. The application's been designed in a way to validate the current status of the nodes, as well as to redirect to the next closest node in the case of that catastrophic failure situation. Great thing is pgEdge platform actually has a variety of APIs that would actually give you distance to user. We're not capturing the user information, actually you're passing that in, right? So knowing that I'm in that greater Los Angeles area, my closest node was that US West, that's no longer available. It's redirecting me to that US East. Now, let me pull up the employee information there. In this case, what I'd like to do is I'd like to make some change to this, right? I'm not having to promote a read node. In this case, this is a multi-master configuration. It is already doing the replication. It is immediately on. There is no downtime for my end user, right? The latency here, as you can see, still highly performant application, as would be expected with a modern application. So I come in here, I take a look at my information for that user in Europe as well, also has that reflected change in there. Now that I've made that, what I want to do is, okay, now perfect. The user's experience is excellent, but that said, what I'd like to do is I'd actually like to bring my West server back up. In the end, AWS, Azure GCP was able to fix that problem. That server is now functional. So what I'll do is I'll just pop back into EC2 here, into AWS here, and I'll start that instance. Now, what I want to see happen here is I want my data to be reflected, as the data changes that I had to also be reflected in my West node, right? So I want there to be that consistency in data, even that ability to handle that disaster circumstance. As well, I want to be redirected back to the next closest node using the latest and greatest data. So let me go ahead and refresh my application here. You'll notice that that node is now back up. I'm being redirected to that. Let me go ahead and pull up the information on my employee, and already the data has been replicated over. Now, this is really great. Like, I'm not promoting read-only nodes. I am using that multi-master configuration within pgEdge to really simplify my data layer, get it at the edge, close to my end users, but tolerant to the inevitable circumstances that are going to arise during business, right? Things happen, regions go down, right? Providers have challenges. Being able to hedge against those particular issues is so critically important, and having a platform such as pgEdge to help and assist and simplify that experience for me is so critically important. So that's really what I wanted to touch on. I'm going to turn this back open for some Q&A, but really appreciate the time for you all today.
Thank you, Mike. And thank you, Philip. This has been great. So let's open it up to some Q&A. We have a first question. How important is scalability when choosing the pgEdge SaaS solution?
Well, because we're built 100% on Postgres, you have the scalability of the Postgres database, but in fact, it's even somewhat better than that because you now have the ability to distribute the load across multiple regions. And so you can actually get a bit of a boost in scalability. So if you're hitting the wall on a single server, single region architecture, you can move to geographic distribution of your workload using pgEdge.
Okay. We have another question. What measures do you currently take to ensure data security?
We take a lot of measures to ensure data security. First of all, with our pgEdge cloud architecture here, we are using what we call the BYO account model. And so it is actually cloud accounts that are under your control. And you probably want to do this in a separate cloud account, not mixed in with other infrastructure that you have. But it's a cloud account under your control. And you can utilize all of the security tooling and compliance requirements that you have across the rest of your cloud infrastructure. You can do that in these pgEdge accounts. So it's not like the traditional sort of SaaS setup where you have no visibility into how the infrastructure is configured, how the security is configured. You've got the ability for your security tooling, for your security teams to get full visibility into that infrastructure because there's actually infrastructure that's residing in your cloud account. There's actually a related question here in the Q&A. Does pgEdge Cloud Platform have PCI DSS compliance? When it comes to compliance, again, taking advantage of that BYO cloud account capability, because it's your environment, whatever compliance you are achieving for your own environment, the pgEdge databases and infrastructure become part of that because it is, again, your environment.
Okay, next question. Can you share any success stories or positive experiences with your pgEdge SaaS solution?
Sure, yeah. So some of our early customers are already seeing some great benefits. So we have one SaaS customer that is using pgEdge multi-region between here and Europe. And so they're getting the benefits of the protection against cloud outages, but also they're much better able to service their European users as a result. More recently, we've been working with an AI company that have deployed pgEdge with the pgvector extension, and they have customers that are far away in Asia, and so using pgEdge, they're able to really get a much better response time for those distant users. So those are just a couple of examples of the companies that we've been working with so far. One thing that we haven't made clear that maybe I should just point out, we focused here on our pgEdge Cloud offering. pgEdge Cloud is actually built on what we call pgEdge Platform, which is the core pgEdge Distributed Postgres database. And you are welcome to utilize either pgEdge Platform for self-hosted software in your own environments, be it on-prem or in your own cloud accounts, or you can use pgEdge Cloud that Mike just walked you through here, which is a managed cloud service where we're taking responsibility for managing that database infrastructure for you.
Okay. The next question, and if anybody has further questions, just a reminder to put it in the Q&A box at the bottom of your screen. We do have a little bit of time left. So the next question, what are the common challenges for transitioning from on-prem Postgres to pgEdge Cloud?
Well, first of all, as I just said there, with pgEdge platform, if you're already using Postgres on-prem and want to stick with that, then you could make use of our pgEdge platform product. Moving from on-prem to pgEdge Cloud, we believe is relatively straightforward. We'd be happy to engage with you and talk through your specific scenario in a little more detail. But again, it is pure Postgres that we're running on top of, and so there's not a lot of application rework that's required to move to pgEdge, whether that's pgEdge platform self-hosted or pgEdge Cloud.
Okay, we have another good question that just came in. How many pgEdge nodes are supported? Are there differences, trade-offs in how they are connected to each other? And then it says in a ring or in a line or any combination.
We're finding that even a relatively small number of nodes can really make a difference in terms of addressing data latency and giving you ultra high availability. In terms of the configuration and our ability to support different architectures, I'm just going to hand that to Dennis if you would like to jump in on that.
So generally speaking, at this point, we recommend between 3 and 5 regions, and then you can have 2 or more synchronous read replicas within a region. So for ultra high availability within a region, you can use synchronous read replicas to make sure that you're not losing any transactions within a region, etc. So as an example, a 9-node configuration, which is 3 nodes in 3 regions and 3 nodes in each region, with 1 master node taken in each region. Now, do you have to have 9 nodes to achieve? It's like, no, you do not. Many customers are understanding it's like, well, I'm going to have synchronous replica 1 in each region, and I'm going to use that as part of my high availability and make sure I can back up each one individually. So we try to give you flexibility there. What we don't believe in is synchronous replication across regions, right? So we will be in the future offering that on a transaction by transaction basis if there's some exceptional case where you want to do that. But in general, the synchronous replication and the quorum support is within a region for really ultra high availability so that you can fail over and switch over a particular node going down and taking right over as the active node in that cluster. That is robust, but up to 5 regions at this point. There's no mathematical thing restricting that, but generally we're seeing 3 to 5 external regions and at least 2 read replicas within a region.
Okay, another question. We probably have time for 1 or 2 more. This is a question regarding scalability. In terms of scalability, how easy do we do horizontal scaling? Is there any limit to how many nodes we can have in one region? And how long does it take to create 1 new node inside 1 region until the data is the data replication is complete?
Yeah, so there's you want me to take that one, Phil?
Please do.
So in terms of horizontal scaling, it's important. Some people will point out, like if you have 2 nodes, 1 on each side of the country, if you send half your load to one, and then that is sending its load to the other, send half your load to the other, so that you have a situation where you're kind of putting half your load in both locations. Either place could take the entire load. But along with PCI and DSS compliance, you can also filter your data so that your are creating scalability by saying certain data, and whether you're filtering at the row level, at the table level, the schema level, or even at the for partition tables, you can filter so that certain data will stay in region and other data will be filtered, so that your reference tables and things like that go everywhere, but your detail table that's country specific, it's like that's regionally scaled and that stays within region. So certainly you can do that, and that's going to help with your data residency requirements as well as your scalability requirements. So that type of filtering can really come in handy. What was the other aspect? There's another aspect of the question that it says I'm in the middle of answering. But anyway, go ahead. If anybody else has any follow-up questions on that, you can go.
Okay. That's all of the questions that are in here. I thought maybe we could share some of the questions that you answered that perhaps people didn't see. Here is a good question. If we are using pgEdge Cloud Platform, for example, we are using AWS base. Does pgEdge set up all the infrastructure as needed using your own AWS account? Or will you set up an infrastructure using our client AWS account?
Yeah, I can take that. So pgEdge Cloud right now does work purely on a BYO account model. As I said earlier, we'd recommend that account be separate from other infrastructure you might have, so that these things don't get mixed up. But if the question is, is it possible for us to actually host in our own accounts on your behalf? That's actually a model that we're looking at, and please stay tuned on that front.
Okay, so one final question. Given the fact that some of the country is strict regulatory government, I don't think we can share our AWS account primary, since we also manage our infrastructure there. Is there any chance that pgEdge will have dedicated AWS account?
Yeah, Kathleen, I'll take it. Phil just kind of answered that. The way I answer the question is, right now we have a bring your own account model. Technically, we also supply using your own account within platform, and we have the technical capability, but not the product feature yet, to be able to run in production on our accounts. So we're considering that. As Philip says, stay tuned as a future. The way I wrote it is that we have that technical capability. Talk to your account rep to try to get that prioritized.
Okay, I think that's everything for today. We just want to thank you so much for joining us, and thank you to Philip and Mike and Dennis and Hari for being part of our presenters and panelists today. And be on the lookout for the replay and also a copy of these slides. Thank you for joining, and have a great day.
And thank you.
Thank you all.